So in this video, we're going to take a look at how to come up with an equation of a plane given 3 points. So we've got A 110, B negative 102, and then C 132. Okay, so go ahead and visualize the situation using the 3D Geogebra calculator. Now you can click over here, but I actually will just type the points. So I'll just say A equals 110. Okay, so I hit enter, it'll just put the point there for me. Then I have B, which is negative 102, so hit enter there. And then C is 132. Now, just because I want to make them different colors, I don't know why, but whatever. So you can go ahead and adjust that. Actually, you can actually click on the point itself, and here you can fill it a different color, whichever. Like, let's say this one's purple. I don't know what this one is going to be, orange or something. Okay, so we can just see what, the difference between them. Okay, so if we want to go ahead and come up with a plane equation, very, very easy. If you go to tools and then you go to plane through 3 points, and then you just click on A, B, and C, that gives us the plane, right? So if we want an actual equation, we're going to go to algebra view and it gives us the equation right there, right? So, but how would you come up with it? You're on the test, nobody's going to give you GeoGebra on the test, unfortunately, right? Isn't that just the coolest thing ever? But how do we do that? Okay, so there are a couple of things you have to do. So first of all, you have to come up with an equation of two vectors that would lie in this plane. Okay, so one of them could be something like AB, and the other one could be AC. It actually doesn't matter as long as these two vectors are not parallel to each other. Because if they're parallel, then you really can't find the cross product. I mean, you can find it, but it's going to be a zero vector, and that's not going to help you. Because you want the vector normal to that plane, right? So you have to find this vector. So AB, how do you find it? Well, we're just going to subtract the components, right? So it'd be negative 1 subtract 1, and then 0 subtract 1, and then 2 subtract 0. So that will give me negative 2, negative 1, 2. Okay, so that's one vector. The second vector will be, for example, AC. You can do BC, you can do whichever one you want, as long as it's not parallel to AB. It's not going to matter on the answer. Okay, so this will be 0, because 1 minus 1 is 0. 3 minus 1, that's 2, and then another 2. Okay, so once you do that, so just imagine that you have these 3 points somewhere, right? This is like A, this is B, this is C. So AB would be this vector right here, right? And then AC would be here. The cross product, we should know that the cross product is always perpendicular to both AB and AC. So the cross product will be something here, right? So this would be, we'll call that N. That's the vector normal to the plane. And the plane contains the ABC, right? The points. That's the plane. Okay, so we need to come up with the normal, and normal is the cross product. Okay, so how do we do that? So we're gonna form a determinant. The first row of the determinant is ijk, which is standard unit vectors. It's really not a real determinant, but it's just a way to remember how to compute cross product. Then we're gonna put negative 2, negative 1, 2, and then I'll put 0, 2, 2, and I need to find the cross product. Okay, how do I do that? First, I will go ahead and imagine that I am deleting these. Okay, so like it's not there. What do I get? Is I get this little 2 by 2 determinant. So remember, when we find the determinant, we multiply the diagonal elements. So we multiply these two first, and then we're gonna subtract, multiply these two. Okay, so what will we get? So we get negative 2, right? And then subtract, well, 2 times 2, that would be 4. So that's our ith component. Okay, so then minus, remember the jth component always negative. You got to remember that. So what do you get? Well, let me just delete the, I don't think I can erase it, but let me see if I can. This is going to be a mess. I'll have to like delete this part and imagine what kind of determinant I'll get. So that'll be negative 2 times 2, right? Like this with that, and then subtract 0 times 2. So that's just going to be negative 4 here. Okay, and then plus k. So what's k? So imagine crossing out the k, right? This, what's left? So what's left is going to be that part, right? So that will be negative 2 times 2 and then subtract 0. Okay, so final answer on the net normal vector, that's going to be negative 6. That's the I component. Then this one will be negative 4, but then there is another negative. So that's a 4. I'm going to write it using components as opposed to IJK. It'll be easier for us. And then negative 4. Now, how do I know that the cross product is correct? So this is something that I would do all the time, especially on tests and stuff like that. If you ever want to know if your cross product is correct, just go ahead and find the dot product of the answer with each of these vectors. And if it's 0, then you're good. So I am going to find the dot product because I want to move on. What if I messed up somewhere, right? I can't go on. I need to check this. So let's go ahead and check it. So remember, the dot product is just a number. So you just multiply x component with x. So that's 12. Then y with this one. So that would be negative 1 times 4. That's negative 4. And then this guy with that guy, that's negative 8. Okay, so that's 0. Okay, so that makes me breathe a lot better. However, I can still mess up. And how can you mess up? Well, it's possible that one of them is 0, but the other one is not. So I really have to check both of them just to be sure. Okay, so I get 0 times negative 6, well, that's 0. And I get 2 times 4, that's 8. And then 2 times negative 4, that's negative 8. Okay, so now I know that this is absolutely correct. Like, there is no way this is wrong. Okay, so once I do that, now I have the normal vector. And I just need 1 point. And then I can come up with the equation of a plane. Because remember, generally speaking, this is equation of a plane. This is the way it looks like. Okay, so why is that, by the way? Because if you take any point, so let's say take A, and imagine that it has coordinates x0, y0, z0. Now take some other point on that plane, and it has some components x, y, z. If you subtract them, you get a general vector that belongs to that plane, right? Because x, y, z change. And what we just found is the dot product of this vector with the normal vector. But because they are orthogonal, the dot product must be 0. So that's what we wrote right here. We found the dot product and made it equal 0. That's where this comes from. So, okay, so what is this ABC? That's the normal vector. That's the components of the normal vector, which we found. That's negative 6, and that's 4, and then that's negative 4. And so we just have to do x minus x0. So if you're asking me what is x0, well, I decided that's the A coordinates. Can I pick B or C? Sure. I mean, go for it. It doesn't matter. I picked A just because it's easier, but you could go for it. Like, once you simplify it, it really will make absolutely no difference. So here we got y minus 1. Here we'll get z minus 0 equals 0. Okay, so just some simple algebra. I'll get negative 6x plus 6. And then here plus 4y minus 4. And then minus 4z equals 0. Okay, so just to pretty this up a little bit, I would get something like this. And then 6 minus 4 is 2. So basically that's it. Now, I want to check this with GeoGebra. Wouldn't that be nice to know if I got this correct? Okay, so there's some difference between what I came up with and what they came up with. So my answer, if I convert it to the format that they have there, they just move in that plus 2 to the other side, becomes minus 2. And so it actually is exactly the same except for a constant multiple. So if I were to divide every single thing by 2, I would get negative 3x plus 2y minus 2z equals negative 1. And so that is exactly the same plane, and I am done.